developer journey on cognitive and data science. It is hosted on github.com/IBM/Watson document classifier. The developer journey is on augmented classification of text with Watson natural language understanding and IBM data science experience. I will refer to them as Watson NLU and IBM DSX. The journey uses Jupyter notebooks in IBM DSX to augment Watson NLU API output in a configurable mechanism for text classification. When the reader or the developer has completed this journey, they will understand how to create and run a Jupyter notebook in DSX. They will learn how to use DSX object storage to store data files and configuration files, as well as access them. The IBM Watson NLU API is used to extract its metadata and then combine the extracted metadata with augmentation from Jupyter Notebook text classification. You will also learn how to extract and format unstructured data using simplified Python functions and some of the libraries that are default available in IBM DSX. The main aspect of this developer journey is around using a configuration file to build layered classification grammar. The classification grammar uses different techniques to do the classification, starting with literal keyword pattern classification, then followed by a regular expression based classification, and the third one being part of speech tags used in a chunking technique classification. The output of this developer journey is a JSON file that is stored in the DSX object storage. This developer journey is intended for developers who want to learn methods to augment their classification techniques on documents. They can use Watson NLU API, get the output of the API metadata, and use this developer journey to augment that output with their own classification grammar as given in the configuration file. This helps the developer in situations where the traditional approach of training a text analytics model doesn't yield expected results, and there is lack of enough data to train the text analytics model. It gives the developers a head start if they want to do a classification of text in a specialized domain, especially in cases where there is no available English parsers for that domain. The journey README gives the architecture that is followed here. The steps outline starting with uploading your data and configuration file into the object storage. The data file refers to the document you want to augment with text classification. The files from object storage are retrieved using a Jupyter notebook in DSX, and the Jupyter notebook calls the Watson NLU API to obtain the metadata and perform augmented text classification on this metadata using a configuration file which is specified as JSON structure. The Jupyter notebook uses Spark as the analytics engine for this, and the results are stored back into object storage. The main components that are referred in the developer journey are IBM Data Science Experience, Bluemix Object Storage, and Watson Natural Language Understanding API. And the main technology featured is Jupyter Notebooks. The journey outlines the steps a developer would need to set up the data science experience, create a Bluemix service, create the notebook in data science experience, how to add the data in configuration file, and update the notebook with the service credentials for data science experience, Bluemix services, as well as data science experience object storage. There are steps to run the notebook, download the results, as well as analyze the results. The steps are outlined below in the README file. The most important aspect of this journey is the configuration file that allows developers to do layered augmented classification. This screen grab shows the configuration file being used in the developer journey. The configuration is done in stages. So for example, the stage highlighted here is base tagging, and you can add more stages here, for example, domain tagging. Each stage has different steps. So you can have steps to tag based on literal keywords. You can see some keywords here as step number one. Um, those can be followed by other steps based on regular expressions, or they can be based on chunking patterns based on part of speech tags. You can enhance the configuration file with your own literal tags, regular expressions, as well as chunking patterns. And you can do them in stages or add more steps. Let me take you to the notebook that I've created for demo purposes in DSX. The notebook contains steps to do the setup, install the necessary packages. It imports the important packages and libraries we need to use in the code here. The configuration we need to do in the notebook around service credentials from Bluemix services, as well as service credential from object storage. The global variables can be defined here. In this case, the developer journey contains the sample text file as well as sample configuration files. There are modules written as functions in the notebook that allow you to do Watson NLU based classification, followed by augmented classification on NLU metadata response. Each step is modularized into a separate function in the notebook. The main function being used here to augment the metadata from Watson NLU API is classify text. There are module functions written to persist and store the config and data file as well as the results as a JSON file. Let me quickly take you through the output that the notebook shows for the text classification done on the sample file. If you look at it, as mentioned before, it does the augmented text classification in stages. So first stage was base tagging, wherein step one was keyword based tagging. So here we can see it has found some keywords and has done the tagging given in the configuration file. That was followed by a regex step wherein it identified a date, a phone number was identified, and a chunking step was followed, which actually identified a noun phrase here. So there were multiple noun phrases identified in the text file. There was also a chunking pattern around name being identified. So you can see in the sample text, name tagging has been done. And there were domain tagging done based on identification of year. The output is given as a JSON file. So Watson NLU output comes as a JSON format. The output of the augmented classification is added to the Watson NLU output, and the combined JSON output is actually stored back as sample text classification.txt file into object storage. You can see, for example, Oxford has been identified a name in previous tab and it has been added to the JSON format here. You can take this developer journey and modify the code and the modular functions to achieve your own augmented classification methodology. You can add steps and stages to the configuration file, and you can use it in conjunction with Watson Natural Language Understanding API to augment its output when you do not have enough data available to train text model for domain. This is the main architecture you would follow when you use this journey. Thank you.